Guys, let's see first. I mean, if we have got a length of three, I mean, there are three matrices involved. How many ways we can break it down? So let's look at the previous example, right? In our previous video, I mean, when we have three matrices, so there are only two ways we can break it down. Either we can break it down into this A1 and A2. I mean, we multiply A1 and A2 first, and then use the product of that, and then multiply with A3. And the second option was that we multiply A2 and A3 first, and then use the product of that to multiply A1. So, for example, so we can conclude that if there are n number of matrices, then we had n minus one number of ways possible to break it down and compute the minimum cost, right? Similarly, just using this formula, I mean, if we have got say A1 multiplied by A2 multiplied by A3 multiplied by A4, for example, we have got n is equal to 4 here in this case. So n is equal to 4, and we from this formula we think that it should be there are total number of three ways possible, right? How three ways? Because first of all, we can let me show that how. Okay, so one way is that I just take this A1 out, and then first of all I multiply A2, A3, and A4 first. So this is one option. Second option would be that I multiply this first and this, right? So it should be in brackets A1 multiplied by A2. This is the second possible way. A3 multiplied by A4. This is second, and the third, as we mentioned, that the formula says that should be three ways. Then the last way would be we multiply these three first, and then multiply this. And use the product of that to multiply A4. So these are only the three ways possible. So we can generalize this formula that if we have got n number of matrices, then there are n minus one ways possible to divide this into several cases, right? So let's go back for length is equal to 3. So here in this case, again, using the same formula, there would be two ways possible, as we have already seen before. So it would be, first of all, let's take 0 first, and we multiply this first. And the second case would be 0 multiplied by 1 first, and use the product of that to multiply with 2. So let's again use this formula. So 1 by 2 we have already calculated, right? So 24 plus, okay, so 1 by 2 when I multiply 1 by 2. So again we have to use this formula, that using the product of this. So 1 by 2, the formula would be 2 and 4, and 0 is 1. So it would be 1 multiplied by 2 multiplied by 4. 1 is the number of rows in 1, which is this formula, and we have already multiplied 1 and 2, which is having dimension of 2 and 4, right? And this is where we got the 2 is the common term between 0 and the product of 1 and 2, and finally the 4 is the column of the product of 1 and 2. So this comes out to be, let me expand it a little bit. So it would be 8 plus 24, which is 32. Guys, I mean, as we have solved all this previous problem in bottom up, so the basic idea is that we start with the base case, and then we go ahead with the higher cases, and then we actually we look for two things. First thing is that whether we can reuse the sub-problems that we have already solved, and if there's any pattern being followed here, whether we can deduce any algorithm which is common for when we are reusing the sub-problems. So here we have seen that we have used for 1 and 2 we have already calculated in our previous here 24, and we are reusing it. And then on top of it, we are calculating this value for 1 and with the product of 1 and 2, we are doing 0. So here we are using this sub-problem we have already solved. So let's see, whether we can deduce an algorithm out of it. So, but so far, the first case is solved that we are actually started reusing the problem that we have already solved. Similarly here as well, right? We can see 0 and 1 is already solved here. So it would be again 6 plus the product of this 0 and 1 would be having dimension of 1 and 3, right? So 1 and 3. So it should be 1 multiplied by, yeah, so 1 and 3 is there, and for 2 is 3 and 4, so it should be 3, right? 3 and multiplied by 4. So this one would be 12 plus 6, which is 18. Okay. Now now we have to choose that which is, now we have to choose for this combination 0 and 1 and 2, what is the minimum cost of operation involved here? If we either choose this option or this option, and we see that 18 is less than 32, right? So this is the best way or the minimum cost involved when we use this type of formula. For 0, 1 and 2, if we multiply 0 and 1 first and then use the product of that to multiply with 2, then we arrive with the minimum cost, not with the first one, but with this one. So I will, for this case, like 0, 1 and 2, right? 0, 1 and 2, here it would come as 18. Now let's move to the second case, which is this. I will use the same formula here, and I'll do it a little bit quicker this time. So for 1 multiplied by 2 multiplied by 3, 2 and 3 we have already calculated here, which is 36. That's why I wrote 36 here. And the product of 2 and 3 would be having 3 by 3. So that's why for 1, it would be number of rows of 1, which is 2. And then the common value is 3, the common column. And then the final column of the product is 3 again. So that's why it's this. And then we will have this product as 54. Similarly, I will calculate the second possible scenario case, that 1 multiplied by 2 multiplied by 3. So 1 by 2 we have already calculated as 24, right? 24 plus the 24 plus 2 multiplied by 4 multiplied by 3. So it would be 48. Again, for this combination, we see that 48 is the minimum cost of operation involved when we use this case. So that's why I will put 48 here. Sorry, 48. Okay. Now this is our final value, because here we exhaust, and this would be our final solution, which is for length is equal to 4. So for length is equal to 4, it will span our all matrices that are involved. We have to multiply all this 4 together, and this is our solution, right? Here we will find our solution for multiplying the minimum cost of operation involved when we are given with 4 matrices multiplication.